Open the CSV file, save as, choose the location where you want to save, and save as type will be Excel workbook. Save as type will be XLS workbook. File, save as, choose the location where you want to save, and save as type. Choose the first option, Excel workbook. Okay, all of you are done. Done, all of you? See, the first and foremost step in data science is exploratory data analysis. The first and foremost step in data science is exploratory data analysis, also called as EDA. This is the first step in data science, EDA. It provides a complete understanding of the data. EDA provides the complete understanding of the data. EDA includes three components. Descriptive statistics plus data visualization plus data aggregation or grouping. The three components of EDA are descriptive statistics, data visualization, and data aggregation or grouping. Once you perform EDA, you will have a complete and thorough understanding of the data, what problems the data has, and what you should do with those problems. Those problems will be tackled in the next step called data pre-processing. After EDA, the data pre-processing will come into picture. Now, the data pre-processing will depend on your EDA. What are all problems you identified in EDA? Those problems will be sorted out using the data pre-processing techniques. So EDA followed by data pre-processing, followed by inferential statistics or hypothesis testing, followed by feature engineering or variable selection, followed by model building and model selection, and finally model deployment. This is the typical data science process. In this whole process, EDA is the starting point, and it is the point where if you not do this step properly, you will have a lot of issues in the next steps, and you may not even be able to build a model at all. So EDA followed by data pre-processing, followed by hypothesis testing, followed by feature engineering or feature selection, followed by model building and model deployment. So this is the process which is typically followed in data science process. So the first step, EDA, is a very critical task which you need to do thoroughly. And EDA is what recruiters also look about. They don't want you to build more machine learning models straight away. You have to do a complete thorough analysis of EDA. In fact, recruiters will look at the EDA that you are performing on the data. what graphs you're using, what type of grouping you're doing, what visualizations and all. Yes. So all those things will be done very, focus will be there on EDA. Your logical thinking and all will be known from EDA. Within EDA, the first step is descriptive statistics. Descriptive statistics, also called as univariate. In descriptive statistics, you have two types: univariate statistics and bivariate statistics. What is univariate statistics? Single variable. They are calculated on single variable. What is bivariate statistics? Two variables. As the name suggests, they describe the data and its distribution and problems or issues in data. So the descriptive statistics will give you a detailed description of the data, its distribution and problems associated with the data. Okay. So let us look at the univariate statistics. So in univariate statistics, what are the statistics? The measures of central tendency. What is central tendency? Midpoint. Midpoint of the data. Central tendency means midpoint of the data. The measures are mean, median, and mode. Next is measures of dispersion. What is dispersion? Scattering of observations around mean. Scattering of observations around mean. What are the metrics? Variance and standard deviation. Scattering of observations around mean. That is called dispersion. Measures of asymmetry. Measures of asymmetry. Asymmetry means how close data is to normal distribution or bell curve, right? How close the data is to normal distribution or bell curve. So measures of asymmetry. Asymmetry will tell you how close the data is to normal distribution. If it is close to normal distribution, it is called symmetrical data. If it is not, asymmetrical data. The two metrics are skewness and kurtosis. Then the measures of location. Location means where the data is located in the, where the observation is located in the data. Quartiles, percentiles, and deciles. The measures of location. The four univariate statistics you need to understand are these three: central tendency, dispersion, asymmetry, and location. And these provide a lot of information. When you calculate them, you will have a lot of information and understanding of the data and what issues or problems you might have with your data. Hey, Akhil. Outer travel from which? So univariate statistics are there. Now, apart from this univariate statistics, we also have certain metrics which are calculated along with these univariate metrics. The first one is count, represented by capital N or small n. So N in statistics is number of observations or count. Then you also have the minimum of the data, the maximum of the data, and then the range of the data, which is max minus min. So these metrics combined, we call them as descriptive statistics. Within descriptives, they call them as univariate statistics. These are all calculated on single variable, only on one variable. And these provide a lot of information about your data. Got this? Now, all of you go to the listing sheet. So among these variables you have, which you think is the most important variable? Look at the variables you have in the sheet. Which variable you think is most important when you're booking the hotel? No. See, Airbnb is purely for budget travelers. People who want to travel at a lowest possible cost, they use these BNBs. So which will be the most important variable? Price. Price will be the most important variable, followed by the number of reviews. Because this is mostly used by Generation Z and all those people who are young and millennial generation. So they would be looking first at price, second they look at the reviews. If ratings is there, they look at the ratings also. But primarily, when you are looking at cost price sensitive customers, price becomes a very critical aspect. So let us understand this price. Go to price, Control Shift down arrow, select the column, Control C, paste it in a new sheet in the same workbook. Control Shift down arrow. Go to the price. Down arrow should be pressed only once. It will automatically select the data range. Control C, go to a new sheet. Paste it in a new sheet. Control V. Got it? Give a column gap. And now we'll give the descriptive statistics. Count, minimum, maximum, range, average, median, mode, variance, standard deviation, skewness, kurtosis, first quartile or Q1 or 25%, second quartile or Q2 or 50% or median, third quartile or Q3 or 75%, interquartile range. Interquartile range, which is Q3 minus Q1. These are the descriptive statistics, which generally gives you a lot of information and which are the mandatory calculations you need to do. Done. Now, always first look the data range. The data range is, mine is in column A, starting from 2, control shift down arrow, 8025. You can see the row numbers, right? So my data range is from A2 column A 8075. You can type small letters also, no problem. My data range is A2 column A 8074 or 75, right? 75 or 74. Sorry, 8025. 8025. Now, the function for count is equal to COUNT count, open bracket, A2 colon A8025. You can type is equal to the function name. COUNT is the function name, followed by parenthesis or round bracket. Within the parenthesis or round bracket, you have to give the data range. Standard function syntax for Excel is equal to followed by the function name, followed by parenthesis, and within the parenthesis, you have to give the data range. Parenthesis is compulsory for every function. Press enter, you will get the value 8024. So this is the function is equal to count, COUNT, open parenthesis, A2 colon A8025. All right. Is equal to min A2 colon A8025. Is equal to min, open bracket, A2 colon A8025. Press enter. The minimum is 0. Is equal to the function name, min function is the name, followed by parenthesis, followed by data range. Python also follows the same function name, followed by parenthesis. Either the parenthesis will be null or you give arguments in parenthesis. Function format is equal to min, open parenthesis, A2 colon A8025. Min is 0. Is equal to max, open bracket, A2 colon A8025. Is equal to max, max, open bracket, A2 colon A8025. See, follow this range syntaxes and all. When you work on very large data, you can't drag. So first find out the data range, use them. It is not case sensitive. Excel is not case sensitive. You can type small letters, it will automatically convert into the right format. So you need not worry about it. We'll be working with very large data in industry. Lakhs and lakhs of rows will be there. So dragging, all those things will not work. So find out the range, note it down in some place and start using it. So maximum is 10,000. Is equal to, select the max cell minus the min cell. What is range? Max minus min, right? Maximum minus minimum is equal to select where you have calculated the maximum cell minus select the cell where you have calculated the minimum. So range is max minus min. This is a formula. Select the cell where you have is equal to, select the cell where you have calculated the maximum minus select the cell where you have calculated the minimum. So the lowest price is 0, the highest price is $10,000. Range is obviously 10,000 because min is 0. Okay, so these metrics which we are calculating here, they provide the initial length of the data. What is the info about size of data? So they provide the info about size of the data. What data you are dealing with? What is the size of that data? That is what is provided by these metrics. So you need to have a thorough, right? How many lakh of rows you are dealing with? What is the min of the row? What is the max of the column? All these things will give you the initial size of the data. What is the size you are dealing with? And how wide data is spread. Got it? Yes? Can you move forward? Now, the next level is the central tendencies. What you call the measures of central tendency. There is no mean in Excel. It is average. Average A2 colon A8025 is equal to average, open bracket, A2 colon A8025. $214 is the average. Okay, is equal to median A2 colon A8025. So median price is 150. Is equal to MODE mode A2 colon A8025. So most repeating number is 100. Is equal to average, is equal to median, is equal to mode. Okay. So these are the central tendencies. Which is the midpoint, the center point of your data. What is the formula for mean? Sigma n divided by n. Sum of numbers divided by count of numbers. How do you calculate median? Yeah. First, what is the step? Yes. Sort data in ascending order. The first step is, what is ascending order? Yes, small to large. Then, if it is even, you will have two medians, M1 plus M2 divided by 2. And if it is odd, the exact midpoint. Exact midpoint. So first you need to sort the data in ascending order. Then if the observations are even, you will have two midpoints, M1 plus M2 divided by 2. And if it is odd, you will have exact midpoint. Okay. And what is mode? Most frequent or occurring. So most frequent or occurring is your mode. Clear? PGA 30 or 32? 30. Other class. All right. Now let us get to dispersion. Variance is equal to var A2 colon A8025. Now you might see dot P and dot S. Dot P represents population or N. What is dot S? Dot S represents sample N minus 1. So you will see dot P and dot S, var dot P, var dot S, right? If you type that. So dot P represents population, which is N. Dot S represents sample, which is N minus 1. There is a population and sample notation in Excel. Is equal to STD EV. A2 colon A8025. Okay. 290 something. Dispersion, scattering of observations around mean. All right. What is the formula for variance? Sigma x minus mean to the power of 2 divided by n minus 1 or n. Sigma x minus mean whole square divided by n minus 1 or n. Square root of variance is standard deviation. Sigma x minus mean whole square divided by n minus 1 or n. Square root of x minus sigma x minus mean whole squared divided by n minus 1 or n is standard deviation. All right, can we move forward? Is equal to SKEW A2 colon A8025 is equal to SKEW A2 colon A8025 skewness. Okay, is equal to KURT A2 colon A8025. Okay, so asymmetry, closeness of data to normal distribution or bell curve. The formula is sigma x minus mean to the power of 3 divided by standard deviation to the power of 3. Sigma x minus mean cube divided by standard deviation cube. X minus mean cube divided by standard deviation cube. Kurtosis is 4. X minus mean to the power of 4 divided by standard deviation to the 4. Okay. Next, quartiles is equal to quartile A2 colon A8025, comma. First give the data range. Then once you insert comma, you will get the values. Is equal to quartile, open bracket, A2 colon A8025, comma, it will suggest the values, comma 1 is for first quartile. That means observations from 0 to 93 fall under first quartile. Quartiles divide the data into 4 equal parts. Is equal to quartile, data range, comma, the quartile number. 1 is for first quartile, 2 is for second quartile, is equal to quartile, open bracket, A2 colon A 8025, comma 2. Second quartile and median are same. Q2 and median are same. Is equal to quartile, A2 colon A 8025, comma 3. Third quartile. Okay. Interquartile range is Q3 minus Q1, third quartile. Select the cell where you calculated third quartile and select the cell where you have calculated the first quartile. Location is where data point is present, is located in which part of data. Okay. And the formulas are n by 4 is first quartile, 2n by 4 second quartile, 3n by 4 third quartile. And Q3 minus Q1 is interquartile range. N by 4th observation will be your first quartile. 2n by 4th observation will be your second quartile, limit for the second quartile. 3n by 4th observation will be your limit for third quartile. Got it? Now, simply calculating is not enough. We need to interpret these metrics. The interpretation is very important. Interpretation of descriptive stats. So when you look at the count, min, and max, you will know the size of the data. Count, the min, the max, and the range will give you the size of data you are dealing with, whether it's a very large data or is a medium range data or a small data. You will come to know from this three metrics. Count, min, max, and range will give you the size of data you are dealing with. Right, you need to have understanding whether dealing with a large scale data or a small scale data or a medium range data, that you will come to know using these metrics. Then the second metrics which are important are the mean and median. Whenever you're checking mean, you should also check median. They must be closer to one another. They must be closer to one another. As mean gets distorted by large values and small values. The problem with mean is it gets affected by larger values and smaller values. So when you're looking at mean, you should also look at median. They should be closer to one another. When I say closer, there is no fixed range, but a common sense range would be, in our case, mean is 214, median is 150. The difference is around $64, which is slightly on a higher side. I would have preferred mean should be less than 200. I would have preferred a mean less than 200, like 180 or 170 or 190. Something would have been a better mean. But in this case, mean is getting distorted by larger values, not the smaller values, larger values, because max is 10,000, right? And when you group the data, you will know what I mean by this thing. So I'll also show the grouping. If mean is distorted, which happens most of the times, median must be considered as midpoint. If mean is distorted, when you are analyzing the data, we will take median as our midpoint. So the mean and median must be compared. Take, for example, I have conducted a test. The marks students got are 65, 67, 90, 92, and 95. Now, if I calculate mean for this, average would be 81.8. This is your average. If I calculate median, it is 90. Now, there is a difference of 9 marks. Now, which is giving you the right representation of data? Is mean giving you the right representation of data? 3 students out of 5 scored above 90. 3 students out of 5 students scored above 90. So which is the right representation here? Median is the right representation here. The problem with mean is these two numbers are affecting. If you tell the teacher that your performance is not good, your students scored 81, it's not correct. The correct representation is majority of the students scored above 90, which is again correctly represented by median. This is the advantage. Median is not distorted, but mean gets affected by smaller values and larger values. If mean is distorted, if there is a significant difference between mean and median, it indicates distortion of mean. And when mean is distorted, median will be our midpoint. Clear? This is again a common interview question, what is mean distortion? Mean distortion means get affected by smaller values and larger values, which will give you wrong picture, particularly in sales data. Right, in sales data, some 2-3 transactions might be very large and you will see average is very high, but median is low. You can't measure the performance based on the average. You have to go with median. So remember this, whenever you calculate mean, you should always calculate median, compare those two metrics. They must be closer to one another as much as possible. There is no fixed range, a commonsensical range will be there. In our case, mean is 214, median is 150. I would have preferred a median of around 180 to 190 or less than 200. That way it is there. So when mean and median are distorted, it indicates outliers. Distortion indicates outliers. What are outliers? Extreme values that fall outside the normal data range. Distortion indicates outliers, which means there are extreme values that fall outside normal data range. Classic example, the price of tomatoes. You are seeing the TV, right? It's a pure outlier. Most of the vegetables are in the price of 60 rupees or per kg, 60 or max to max 80. But outlier is tomato, which is at 150 rupees. So outliers are extreme values that fall outside the normal data range. So if there is mean distortion is there, it indicates, it's the first indication that outliers are present in your data. And outliers will affect your analysis. Now, what to do with outliers, we will discuss in the further sessions. When we talk about data pre-processing, then we will talk about outliers. Any doubts? Clear? The next set of numbers you should look at is the dispersion, particularly standard deviation. For standard deviation, no fixed range. There is no fixed range, but lower the value, the better. Lower the value, the better. Now, how will you say lower value? Lower value depends on the mathematical size, on unit size, like tens, hundreds, thousands, lakhs, millions. So, what is the concept of lower? It depends on the unit size. Now, in our case, the standard deviation is $290, which is considerably higher. I would have preferred a standard deviation less than 100 because our dollar prices are from 0 to 10,000. Most of the prices will be in between 0 to 500 or 0 to 200. Because low cost budget travelers, right? So I would have preferred a standard deviation less than 100. But here the standard deviation is very high. 290 is a very large number, considering most of your data is in hundreds. $100, $50, $150 is the normal range. Considering that normal range, 290 is a very, very high standard deviation. Now, high standard deviation also indicates outliers. Higher standard deviation also indicates outliers. Higher standard deviation indicates outliers. So you have to be careful when you're looking at it. So here, I would have preferred a standard deviation of less than 100. Because of the range is very wide, our deviance, the standard deviation also will be very high. Right. So if you put dots and put all these observations around the midpoint, the scattering will be very, very large. That is what standard deviation means. That means observations are far away from the mean. Observations are far away from the mean. So the scattering is very large. If scattering is very large, it indicates high deviance. High deviance indicates outliers. Right? Next come our skewness and kurtosis. Normal distribution. Are you guys familiar with bell curve or normal distribution? So skewness and kurtosis, when you look at these values, you have to understand the value first. You will look for whether the value is the mathematical sign is very important for skewness. If the skewness is positive, the peak of the curve will be onto the left side. The peak of the curve onto the left side. If skewness is 0, this is normal distribution or bell curve. Skewness is 0 means normal distribution or bell curve. If skewness is negative value, then the peak of the curve is onto the right side. So for skewness, we are bothered about two things, whether it is a positive value or negative value. If it is positive, the peak of the curve will be on the left side. If it is negative, the peak of the curve will be on the right side. Second, how close it is to 0. Sometimes we generally skewness above 5 is a problem. It's a problematic scenarios. So that creates a problem in your data. Now, what is our value here? We have a considerably high skewness, which is 10. Positive skewness, very, very 10. So you'll have a very narrow curve. A very narrow, tall curve will be there. The higher the skewness, the narrower the curve will become. Right. So it will be very, very narrow curve, and kurtosis is also very, very high. So for kurtosis is equal to 3 is considered as normal distribution. Greater than 3 is positive, which becomes narrow and tall. Less than 3 is negative, which is flat and wide. Tall and narrow is positive kurtosis. Flat and wide is negative kurtosis. And is equal to 3 is normal distribution or bell curve. Look at our kurtosis 220 something, which indicates it's a very, very, very high narrow peak. You can identify them using the visualizations. I will show you how to do the visualizations, but this is the interpretation of skewness and kurtosis. So positive skewness, the peak of the curve is on left side, and negative skewness, peak of curve is on right side, zero skewness means normal distribution or bell curve. Positive kurtosis, which is greater than 3, tall and narrow peak. Negative kurtosis, which is less than 3, flat and wide peak. And zero kurtosis, which is equal to 3, normal distribution or bell curve. So this is the interpretation of skewness and kurtosis, which is very, very important for numerical data. Whenever you see numeric variables in your data, you need to understand the skewness and kurtosis because they will affect the model performance. They will have a direct effect on the performance of the model. Be it in dependent variable or in independent variable, skewness and kurtosis has a big effect. So we need to check them before building the algorithm. Of course, there are algorithms that are not affected by skewness and kurtosis, like tree-based algorithms, decision tree, random forest, and all. They are not affected by skewness. So most of the times in real-time data, we cannot correct skewness. So what we have to do, we have to use algorithms that are resistant to skewness, like decision tree and random forest. Okay. And the interpretation of quartiles. So where the price is it in top 75% or bottom 25%? You know, we talk about top 80%, bottom 20% like that, right? So quartiles will tell you where the data point, where the price is located. So as per our data, if the hotel price, if the property price is $120, it will fall under second quartile. If the property price is in $120, it will fall in second quartile because 93 to 150 is second quartile. 0 to 93 is first quartile. If it is $70, it falls under first quartile. If it is $120, it falls under second quartile. If it is say $180 or $200, it will fall in the third quartile because the range for third quartile is 150 to 240. If it is above 240, it falls under fourth quartile or maximum. So if you are looking at Q0, Q0 is the minimum of your data. Q4 is the maximum of your data. Q0 is the min, Q4 is the maximum. So where the price is falling, in which category? Is it falling in the higher categories? Higher categories are Q3 and above. Lower categories are Q1 and below. Medium range categories are Q1 to Q3. Medium range categories are Q1 to Q3. Lower range categories are less than Q1. Higher range categories are greater than Q3. So the location of the data is also required to understand the categorizations. Whether the property is high, medium, low, right? We have this categorization, high price, medium price, and low price. For that, we use quartiles. Greater than third quartile will be high price. Q1 to Q3 quartile will be medium price. Less than Q1 quartile would be low price. So that is how the categorizations, the locations will help us to interpret. So quartiles will help us to do high, medium, low analysis. Categorizing. Like greater than Q3 is generally categorized as high, greater than Q1 and less than Q3 is categorized as medium, and less than Q1 is categorized as low. Simple high, medium, low categorization, which is widely used, right? So this quartiles will help us to do these sort of categorizations, which will also help us in analyzing the data. I forgot, for quartiles also you need to sort the data in ascending order. Forgot. For quartiles also, sort data in ascending order first. Quartiles sort data in ascending order. And then we calculate n by 4, 2n by 4 and all. So sorting the data in ascending order is must. Okay. So basically, what is your final interpretation? Price is distorted with outliers. There is outliers. So price is distorted. So we will take median price as our analysis point. So we will use median price as our analysis point. So you can say the final interpretation would be price is highly highly skewed, very high kurtosis, not high, very high kurtosis, and outliers are present. Median price is right representation of data. High skewness, high kurtosis, presence of outliers, and even high standard deviation, right? High standard deviation and outliers are present. Median price is the right representation of data. This is what descriptive statistics is telling us regarding the variable price. All right. Copy the column called number of reviews. Paste it in a new sheet. Number of reviews. Calculate the metrics. Calculate the metrics for number of reviews. First, copy paste the column into new sheet. Copy the metrics also from the previous sheet. So is equal to count A2 colon A 8025. So is equal to min A2 colon A 8025 is equal to max A2 colon A 8025 is equal to max minus min is equal to average A2 colon A 8025 is equal to median A2 colon A 8025 is equal to mode A2 colon A 8025 is equal to var A2 colon A 8025. STDEV A2 colon A 8025 is equal to skew A2 colon A 8025 is equal to cut A2 colon A 8025 is equal to quartile A2 colon A 8025. Oh, sorry, comma 1 is equal to quartile A2 colon A 8025, comma 2 is equal to quartile A2 colon A 8025, comma 3 is equal to Q3 minus Q1. Right? All of you got the same values? Yes? Can you move forward? Sheet 1 is notes, sheet 2 is price, sheet 3 is number of reviews. Okay. Now, let us go to the core sheet. Another interesting way of analyzing the data is using pivot tables. So pivot tables help us to do a lot of analysis, both statistical as well as non-statistical, like frequency counts and all. So select any single cell on data, select any single cell on data, go to insert. The first one is pivot table. Select any single cell on data, go to insert tab, left first one is pivot table. You'll get a pop-up like this. The table range is automatically selected. Let it be new worksheet, click OK. Select any single cell on data, go to insert, left side first option, pivot table, click on it, a pop-up window will come. Data range is automatically selected. Let it be new worksheet, click OK. It will create a pivot table like this. Right? All of you got this? Pivot table sheet. So pivot tables help us to work with both numeric data as well as non-numeric data, and a combination of numeric and non-numeric analysis also. So pivot tables will help us to do numeric analysis, non-numeric analysis, and a combination of numeric and non-numeric analysis. So let us do, we are continuing our descriptive statistics. Let us further take it ahead. Now you can see the list of variables on top, right? All of you can see it. Now drag price to rows. Drag price to rows. Drag price to rows. Right? All of you got this? Like this? Right click on any single cell. You have something called group. If you get sum of price, you have to say don't summarize. Click on this. There will be down arrow, right? There is a down arrow next to that price here. Drop down. Click on it. You will see don't summarize. Right? You got it? Value field settings or don't summarize option will be there. You got it? Click on the drill down. What you got in drill down? Value field settings. You got it? Don't summarize option will be there. Where it is? Where is it? No, don't put it in values. Put it in rows. If you put it in values, it will be by default sum. So I said drag the price to rows. Right click on any single cell of data. Right click on any single cell of data. You have something called group. Right click on any single cell of data. Click on group. It automatically finds the files what you call starting and ending. Right. Starting is 0, ending is 10,000. It automatically. Now, by is the class interval. What should be the class interval? Let us say we want to take $50 as our class interval. It is giving 1,000, which is a very large interval. We will take 50 as our class interval and click OK. Now you can see class intervals are created. 0 to 49, 50 to 99, 100 to 149. Right? Now drag price to values. Let it be in rows, drag price to values. Now you see the frequencies. So within 0 to 49, there are 581 properties. 50 to 99, 1,679 properties. 100 to $149, 1,700 properties. Count of price. Right. So majority of the properties are in which category? I think less than 400. See, 7,264. Our data is how much? 8,024, right? 8,024, 7,200 are less than 7, or you can take up to $500. 7,491 sum. You can see the bottom. If you select those values, you can see sum here, right? Yes. Out of 8,024, 7,000 properties are less than 500. Right. So we have to restructure our grouping. Go back to group, ending at instead of 10,000, give 500. So it will create a new category called greater than 500 and put all greater than 500 into one category. Okay, click OK. Now see, greater than 500, 519 properties are there. So majority of our properties are in the price of less than $500. Now this is called grouping, where we found out. So we have outliers which are greater than 500. These are all properties which are affecting our data, these prices data. So you can copy this table, Control C, go to a new sheet. Don't paste it directly, paste special. Click on paste special, values and number formatting. There is a down arrow below paste, right? Drill down below paste. Click on it. First, select the table. Go to the pivot table sheet. Select the table. Control C. Go to a new sheet. Select any single cell. Click on the arrow below paste. You will see paste special, or you can see the second paste values and number formatting. 1, 2, 3 %. paste values option will be there. In that you will see 1 to 3%. Second category. Paste it like this. Because if you copy paste it, again pivot table will get copy pasted. It will create problems. Right? So this is a frequency distribution table. What is this? This is a frequency distribution table. You remember high school statistics? We do have class intervals. This is class interval, lower limit and upper limit. And then you're counting the how many properties are there in that particular category. Now, if I want to present this data in a graph format, what graph should I use? Okay, go to insert. You can use recommended charts. Which one would be better? Vertical or horizontal? Horizontal will be better option, right? Horizontal will be better option. You can compare easily, right? Now in format, you can see a lot of predefined formats are there. You can use any of these predefined formats. Or I think we'll use in chart design, you see a lot of predefined formats, right? Add chart element, data labels, outside end. So if you click on the price, you have this chart tools, no? On top. In chart tools, you will get all these options. If you click on chart on top, you will see chart tools, chart design. On top, you will see. Go to chart design and you will see the chart elements, add chart element. Any doubts, you call me, I'll come and assist you. Add chart element. Left side you have the first option. In that you see data labels. Choose outside end. Got it? So majority of properties in the city of Chicago are in the range of $100 to $150, followed by $50 to $100. Majority of properties are in the range of $100 to $150, followed by $50 to $100, followed by $150 to $200. So Chicago is slightly costly city. Got it, all of you? Any doubts? Any doubts? Please call me. I'll come and help you. You can choose any chart design, your choice. Not that you have to use this one only. All right, got this? Yeah, got it, all of you? Remove price. So I want you to group number of reviews. Group number of reviews. Empty the windows. Empty the 4 windows. And I want you to group number of reviews. So drag number of reviews to rows. Right click on a single cell, group by 20. What is the class interval you are taking? 10. Then drag number of reviews to values. So majority are between 0 to 9. So we can reduce it to 100. Ending at 100. So I'll take it as greater than 100, 1110 reviews. Okay, copy the table. Control C, go to the same sheet. Below, paste special, values and number formatting. Don't paste directly, paste special, values and number formatting. And when you're plotting, do not select the grand total. When you are charting, do not select the grand total. It will distort the graph completely. For this, you can use donut chart also. There is this donut chart also you can use with labels. Donut chart. In insert, pie chart is there, no? Here, you will see donut. In pie charts, you'll see donut chart. Donut chart is also a very interesting chart. Do not select the total. Got it, all of you? Yeah. Now, till now, we have worked with non-numeric data. Sorry, till now we have worked with numeric data. Okay. We also have non-numeric data, right? If you look at our data file, you have non-numeric data like neighborhood, room type, right? Then your name, all these things are non-numeric or text data. So one of the important variable is room type. Drag room type to rows. There are 4 types of room types are there: entire home apartment, hotel room, private room, shared room. Drag again room type to values. You will know how many properties are there in each category. Okay, room type to rows, drag again room type to values. You will get the frequencies of the categorizations. Now, this is not sorted. You need to sort largest to smallest. Oh, sorry. Select the values, home tab, sort and filter, largest to smallest. Home tab, sort and filter, largest to smallest. Got it? Don't select grand total. So now we are entire home apartment, largest property, followed by private room, followed by share room, followed by hotel room. Copy the data. Use same sheet where you have created visualizations. Select a cell, paste special, values and number formatting. The best is pivot pie diagram. Best is pie diagram. Pie diagram with percentages. Got this, all of you? Now go back to the pivot table. Neighborhood wise properties. I want to know neighborhood wise how many properties are there. Drag neighborhood to rows. Again, drag neighborhood to values. Select the values. Sort and filter largest to smallest. Near north side has most properties: Westtown, Lakeview, near west side, Logan Square, Loop, Lincoln Park. Sort it to highest to lowest, largest to smallest. Neighborhood. Within Chicago City, which neighborhood has highest properties? This is a good data set for Power BI also. So we'll reduce the properties to greater than 100. We'll do the graph for only more than 50. greater than 50 properties, which neighborhoods you can see here. Got it, all of you? Click on the chart. You will get the data range. See, once you click on the chart, you'll get the data range, right? Highlighted like this. Come to the bottom, you can see double arrow here. Left side of your cursor, hold down and drag up. Once you click on the chart, data range will be visible. Come to the left bottom blue thing, you will see a double arrow. Hold your left cursor down and move it up. You have to press left side of your touch or left side of your mouse and then drag it up. So the graph will automatically adjust to that particular range. Got this? So I've taken properties, neighborhoods with greater than 50 properties. Got this, all of you? So next is cross tabulation. Cross tabulation is frequency table of two non-numeric variables. Cross tabulation is frequency table of two non-numeric variables. Now, another non-numeric variable we worked upon is room type. Drag room type to columns. Neighborhood rows, room type to columns, any one of them to values. Neighborhood to rows, room type to columns, any one of them to values. This is called cross tabulation, frequency table of non-numeric data, two non-numeric variables. Anything, any one of them, neighborhood or room type, any one of them. And it should be count, not sum. Okay. Now you can copy the table. Control C, go to the same sheet, which one you have done previously. Below, paste special, values and number formatting. Don't select the grand totals. Don't select the grand total, both column and row. Select the actual data, insert. Stacked column. In column, second one, stacked column. Don't select the grand totals. In column chart, second one, stacked column. Okay, you'll get a graph like this. Move it to the top. So what I'll do is I'll do the same thing. I'll take greater than 50 properties as the categorization, and you can see the categories, stacked column chart. So center, I can put. So north side has mostly what properties? Entire home apartment, followed by private room, followed by hotel room and shared room. Right? The categorization, stacked column chart. Stacked column chart. Got it? Normal stacked column, not 100%. Stacked column. Second one, in cluster column, say insert column charts, second option, stacked column. You can see here. Insert column charts, stacked column. First one is cluster column. Second one is the stacked column. And do not select grand totals. I have dragged it bigger. Okay. Got it, all of you? So the largest category is entire home or apartment. Got this, all of you? Yeah. Now go back to the pivot table. Empty all windows. Drag up. Okay. Now drag price to rows in automatically groups. We have already grouped, right? Drag price to rows, it is automatically grouped, right? Now move price to columns. Move it to columns. Drag neighborhood to rows. Drag any one of them to values. So you will know which price category, which properties are there. Select grand total. Go to home tab. Filter largest to smallest. So in near north side, most of the properties are what category? 150 to $199. In north side, most of the properties are 150 to 199, followed by 100 to 149, followed by greater than 500. Right? price to columns, neighborhood to rows, drag any one of them to values, it has to be count. Now you got the table of price-wise segregation of neighborhoods. In neighborhood, where north side, how many rooms are there between 0 to 49? 19 properties are there. 50 to 99, 76 properties are there. 100 to 149, 169. 150 to 199, 193. So largest category in near north side is 150 to $200. Zero to 49, most of the properties are in New City, 30. No. South Shore, 38. Bridgeport, 44. I think Bridgeport is the lowest. Bridgeport has lowest property, price ones. Categorization based on price categories. Got it? All of you? What happened? Group it now. What is there? Group it and then move it to columns. Drag it to row, group it, and then move the variable to column. Then drag neighborhood to rows. First drag price to rows. Here you might be using older version of Excel. First drag price to rows, group it. Starting 0, ending at 500 by 50. Then move it to price. Drag price from rows to columns. Then drag neighborhood. It will be there. It will be there. Check. Which one? So you have to sort it now. See here. Go and sort it. Sort the grand total. Smallest to largest. Okay, no problem. No issues. So these are the properties within the price ranges. Control C, go to sheet 5, and I'll scroll down to the end. Paste special values and number formatting. Right? Control S. We're getting the data based on price. Based on price. Got it? No, we can't chart this now because the data is very large. No? So it has to be kept as table format only. Suppose I want to know the average price. All you have to do is remove count of neighborhood from values, drag price to values, and make it, click on value field settings, average. Click on value field settings, average. Drag price to values, click on drill down. The bottom first one will be value field settings. Change the value field settings to average. So you'll come to know the average price of in each category. All right. I want to know room type based average price. What is the room type based average price? Find out room type based average price. Room type based average price. For each room type, what is the average price? Simple. Drag room type to rows. Drag price to values and change it to average. Entire home apartment is average $243. Hotel room is $187. Private room is $115. Shared room is $48. Average price by neighborhood. Just replace room type with neighborhood. Just drag out room type and drag neighborhood. And sort it. Clearing has the highest price following the Lincoln Park near North Side, Weston Loop. You can see the highest average prices based on neighborhoods. Right? So a lot of analysis you can do. This exploratory data analysis is must. We have to do this to understand the market, what the data. Here we are looking at the data, how, which areas, what I have. It's very important for us to do this. Power BI is done for you. This is a very good data for Power BI also. Whatever you are doing, you can do it in a single dashboard in Power BI. Okay. Now let us get to Python. Same analysis will replicate in Python. So open the Jupyter notebook. Create a new folder. Here. New Python 3 Jupyter notebook. All right. All of you opened a new Jupyter notebook. Now, in Python, the libraries are very important. The libraries are very important. When you start any project or anything in Python, you need to import 3 mandatory libraries. The first one is Pandas. Pandas library is for data frame or data table. In Excel, we call it as data table. Like how we work now, no? It is a data table. Data frame based operations. All functions, predefined functions related to data frame operations like read files, merge files, reshape data, concat, etc. are in this library. There are thousands of functions in Pandas library. that work on data frame. What is a data frame? Data frame is by default rows are observations and columns are variables. Right? In the Excel sheet which we worked on, rows are observations, columns are variables. That we call it as a data frame, also called as a data table. So Pandas library is a library that works on data frames or data tables. Because by default, most of the time when you import data from databases like Oracle or SAP, Mongo or anything, the data will be in a table format. It will be a CSV file in table format. So Pandas is a library that is meant to work on data frame based operations. Read CSV, read Excel, all these operations which are related to data frames like merging, reshaping, calculating descriptive statistics, plotting, all are there in Pandas library. So it's a very important library which you need to import. The second library is matplotlib.pyplot. This is for data visualization, particularly adjusting plot window size, axis labels, fonts, etc. Matplotlib.pyplot is a data visualization library. If you want to increase the plot window size, if you want to reshape the axes, X, Y axes, all those things you can do using this library. The third is NumPy, the core library of Python. Array or list-based operations. Arrays or lists are the fundamental data structure in Python. Array or list-based operations. Arrays or lists start and end with square brackets and elements separated by comma. NumPy. NumPy is the core library of Python. Even if you give the data as a table format, in the backend, Python will break it into arrays. And then the computational processes will be executed. So even if you give the data as data table, in the backend, when you are doing any computational process, Python will break it into individual arrays. And those arrays will be processed. So when you do any computation in Python, the output will be arrays. Again, we have to convert it back to data frames by using pd.pandas.dataframe function is there, which will convert arrays to data frame structure. So NumPy library is the core library of Python that is designed to work with arrays or lists. Arrays or lists start with square brackets. Elements in the brackets are separated by comma. Now, there are certain sub-packages in NumPy that will be imported along with, once you say import NumPy, these sub-packages will also be imported. One is scipy.stats. This is for statistical analysis in Python. One of the library within NumPy. Once you import NumPy, this library is also automatically imported. Scipy.stats. Stats models. This is for time series or IoT data. Internet of Things data is time series data, sensors based data. For IoT data analysis or time series analysis, we have stats models. sklearn. This is the machine learning library of Python. All the functions related to machine learning, right from pre-processing to algorithms to model selections, model validations, everything is there in this library called sklearn. sklearn is a library for machine learning. All the algorithms are available within this library. This library is subpart of NumPy. Once you import NumPy, this also will get imported. And sklearn is our core library for ML. Core library for ML. All the algorithms, regression algorithms, classification algorithms, clustering, dimensionality reduction, all algorithms are available in sklearn. All types of pre-processing, missing value imputations, all sort of pre-processings can be done using sklearn. Data transformations, feature selection, feature engineering, everything is there in this library called sklearn. Apart from these three libraries, there are other libraries which we need to import. Right? NLTK. This is for natural language processing or text data, the core library in Python for natural language processing. He will work on text because on internet, even now, so more than 60% is text data. So natural language processing is all about text mining, language translation, autofilling, speech to text or voice to text, voice assistants like Siri, Echo, all these things come under NLP. Then TensorFlow, deep learning neural networks, image processing. TensorFlow is a library which is developed by Google guys, which is actively developed by Google developers, which is used for deep learning, which is basically neural networks for image processing, large-scale image processing. All this image processing can be easily done using this. So we will work on these libraries and we'll also import other libraries as and when we require. But these are the core libraries in Python that we need to know. All lists, dictionaries, sets, and tuples is done. Huh? So you are familiar with all those things, right? List, tuples, sets, and dictionaries. So import the libraries. Import pandas as PD. Import NumPy as NP. Import matplotlib.pyplot as PLT. Percentage matplotlib inline. Then we will set up the working directory. All of you can create a folder anywhere on your system, name it Python datasets or Python data or whatever name you want to give. Create a folder anywhere on your system. Name it Python or Python datasets or whatever name you want to give, you can give. We will set up that folder as our working directory. Create the folder. And move the file listings.csv to that folder. CSV file, not the Excel file. CSV file is there, no? Not the Excel file. CSV file will be there in your downloads or somewhere. Okay. Move it to my folder is datasets. So I have a predefined folder where I'm moving it. It is datasets. Or you create whatever folder you want to create a folder first and then move the file into that folder. Okay. Now right click on the folder, go to the folder. Open the folder. Right click anywhere on the folder. Properties. Right click anywhere on the folder. Properties. First create a folder. Right click the folder or open the folder. Open the folder and in that folder anywhere right click properties. In properties you will see security tab. General sharing and security is there. Go to security. First one, object name, you will see the complete path. Copy the path. C colon something will be there. Copy the path. Okay. So right click, go to properties and then get the path in security tab. Import IO %CD Windows laptops double quotes. Give double quotes and paste the path and shift enter. Double quotes, %CD space double quotes and paste the path. Import IO %CD double quotes and paste the path and run it. Now you have set the path. The file, you can move the file into that folder, listings.csv. Chicago BNB is equal to pd.read_csv Chicago_listings.csv. Right click on the folder, open the folder, right click anywhere, not on the file. Right click anywhere in the folder, properties, security tab, general sharing and security will be there. Security tab, in that first one, you will see the path, object name, path will be there. Copy the path, do not copy the object name, only the path, C colon or something will be there. Copy the path. Go to Python, import IO, %CD, double quotes. Within double quotes, paste the path and run shift enter. Got it, all of you? And once you move the file there, every time you can save this into a text file. Every time you want to import the data, put the data into that folder and just use this. Or if you're putting another folder in the folder, add the folder name and then put it. For %CD space, double quotes and then the path. Within the double quotes, you have to paste the path. Path is that properties path. Please. There is space now. Consider there is space. You say that. Unacceptable. Properties, go to properties. Security tab. Select the path directly. No extra space. Go to the extend panel. Mac. That is Mac. Windows, that's what I'm telling you. Windows will start missing. Mac, there's a difference. No, set the path. No, that is not available. No, that will not against. That will not come down. It will say path not. That's all. Import IO, set the path and then use it. That is not the best way. Don't upload it into Jupyter Notebook. You have to put it in a folder and then do it. See, double quotes I'm telling you. Windows laptop, you should use double. There is a single quote. For some laptops it will come. For some laptops it will come. So actually, you might have calculate some extra thing. What are the already open. Click on this. Windows are open. Click on this. Select the part. When you select the part, don't select anything before and after. Exactly, you come from this side. Control C. Go to the thing. First put double quotes. Double quotes. One is control B. There is copy of part. There should not be any before and after. So exact part of the part. Got it? You say problem. You what is this here? When is this not found? Did you update the Python correctly? So remember this process of importing the data. You have to import the data like this. Because in industry, you will not import one file. You might be importing 10 files, 15 files. So you have to set the folder, and from the folder, you will import those multiple files. You will write a for loop and input all the files into in one go. Change the directory. First, fix the directory where your files are there. Then only you can import multiple files. You have to set the directory first, wherever you are having those multiple files, and then you will write a loop to import all those files. When we work on multiple files, I'll tell you how to import the multiple file data point. So set the path to the folder. You can do any folder anywhere in your system, except the cloud ones. Cloud ones are different. If you are working on cloud or OneDrive, that's a different process. You have to use the cloud version only.
That is not for every like Visual Studio.
Equals to?
Like does it works in Visual Studio and
no.
Google Colab?
No. Colab is different. Colab, you have to first upload the file into the drive. First, you have to do Google Drive. Or if you want temporarily, you can do it temporary file upload. And from there, same process. You copy path, paste it. Two options are there, Colab. Put it as temporary. That means only during the session. Once you close the session, the file will also be eliminated. Or else you mount your Google Drive to Google Colab, put your data file in your Google Drive, then you can put the same process. Copy the path, put it there. For that, you have to first mount your drive. One-time process where you'll get a large password, copy paste in the box and say, once you mount the drive, you can use it till you update the Python. So mount the Google Drive and then we'll work on it. We also have sessions where we'll work on large scale data.
Okay.
Your 8 GB RAM or 6 GB RAM will not work. Google Colab provides 13 GB RAM. So we'll work on, when you're working on that large scale data, we'll be uploading the data directly into Drive and do it.
For me, that's why I'm using Google Colab.
Why it is giving problem?
It is getting flickering.
Huh?
It is getting flickering.
Okay. Okay.
I understand using Google Colab.
If you're using Google Colab, you have two options. Did you mount your drive?
Means I'm importing like from Google Colab, import files.
That you have to run.
Yes.
But before that, instead of that, you can mount your drive.
Yeah, from drive also connect.
You can do it from drive. So
Like
in Google,
files and.
yeah. We'll work on Google Colab because web scraping and all will work on there only. Large scale data when you're dealing with. So you can upload the file here.
Yes.
I
added this option and other one is like.
To Google Drive also. Yeah, you can do any option. So you can mount the drive. See, this is the drive. You can mount it. If I click it, it will automatically run this thing. So you have to run this and then mount the drive and you can directly get it. Yes. You got the data, right?
Yes, I got it.
Okay, all of you are till here? Now, whenever you get the data, the first thing is info. Info is the first function we run, which will give you the complete understanding of your data in terms of the size. 8,024 rows, 18 columns. That means 8,024 observations, 18 variables, right? Data structure is data frame. See, it's a data frame. Number of observations is 8024. Number of variables is 18. And you also get individual variables data types. Int 64, float 64, object. And if the data has missing values, you'll come to know here. If any, see, this is 0. That means you can delete this. This column has 0 data. This column has 0 data. Neighborhood group has 0 data. You can delete it. When there is no data, we can't do. And you can see there are two variables, last review and reviews month, they have missing values because their size is less than, even license has missing values. Any variable that has less than 8,024, that variable has missing values. So the first indication of missing values will come from the info function. You'll also find 0 data columns. We'll delete them. If you have any duplicate columns, you can find them here easily, and then we can delete them. All this data pre-processing initial ideas, you can get it. So this info is a very important function, which will give you the, particularly important is the variable types and the missing value structure. So this is the info we have. So this will give us the count and all. Then comes your Chicago BNB. Type the 3 letters and tab. Type the 3 letters and tab, auto-filling. 95% of errors are spelling mistakes. Don't type. Type the 3 letters, press the tab on your laptop, auto-filling. CHI or whatever name, tab, dot, HEA, head. Dot head will give you the first 5 rows of your data. First 5 rows of data. Dot head. If you want more, you put the number in parenthesis. Specify the integer in parenthesis for more. You can give any number. You are saying 100, right? So what you have to do is, you have to, the window size is constrained. Let me do it in the second one. So one more thing you need to understand is, there is a limitation in window size. To alter the window size, pd dot set underscore option, double quotes, display dot max underscore rows, comma, 100. Whatever you want, that many rows, you specify the number. Now you can do it. Chicago BNB dot head 100. See, it will give you the 100 rows. Got it? So no, it will give you the complete 100, and then you'll get all colon and all those things again. So that is not a good method. We need this because when you are working with large data, if you have, like in case of our neighborhoods, we have around 80 neighborhoods. When you do value counts, it will not give you the complete data. So you have to display dot max rows, comma 80. And then you will see the complete data output. PD dot set underscore option, display dot max underscore rows, comma, specify the number of rows you want to display. The plot window will automatically adjust to that size.
If you want 150, we have to change that.
100 to 150. Got it? So these type of commands, open a text file and save them. Okay, this formatting commands and all, if needed, even the input IO percentage this thing, your default folder, save it in a text file, not in Word document. Because in Word document, it will create special characters. Open a text file, .txt file, and then save these things as a reference. Okay. Chicago BNB dot tail. Tail will be the last file. Then one other important thing is columns, the name of the variables. The name of the variables. Because if the variable name does not match, it will give you error. Did you guys study indexing? Character indexing and numeric indexing? So, just for indexing or accessing specific rows or columns. There are two types of indexing. Character indexing. What is character indexing? Indexing by name of variable. Next one is numeric indexing. Indexing by row or column number. Row or column number. Character indexing. Single variable. There are two types. Data frame name dot variable name or data frame name square bracket single quotes or double quotes variable name. Two methods are there. They have data frame name dot variable name or data frame name square bracket single quotes or double quotes variable name. Now, this method is used when space is there in variable name. So whenever you have space in variable name, dot will not work. So the second method is used when there is space in the variable name. You will see sometimes in your real-time data, you have spaces in the variable names. Then the only way to access variables is square brackets and quotes. either single or double quotes. So single variable is our data frame is Chicago BNB dot price dot head, or Chicago BNB square bracket single quotes or double quotes price dot head. Single variable character indexing. Data frame name dot variable name without space if the variable has no space. If it has space, data frame name single square brackets, single or double quotes. You can use anything, single quotes or double quotes. Okay. Right. Character indexing, multi-column. Character indexing, how will you do multiple variables? Multiple variables, character indexing. Data frame name, double square brackets. Data frame name, double square brackets, variable 1, comma, variable 2, comma, variable 3 in quotes. Name of the variables in quotes. Double square brackets. Character indexing multiple variables like this. Chicago BNB, double square brackets, single quotes, price, comma, single quotes, number underscore of underscore reviews, or you can copy paste from column output, comma, minimum underscore nights. The name of the variable should exactly match. If there is a mismatch, you'll get an error. So you can copy paste the variable names from the columns command. Here the column commands is there now. So price, all three are simultaneous columns. Control C, Control V. Okay, you can copy from here. Because don't try to type, it will be errors. Always, if you want to column names, run the Chicago dot columns. You'll get the list of variables or names, copy paste. Your errors will go. So this is the command structure. For multiple column character indexing, double square brackets. Outer square brackets for selection. Inner square brackets is multiple arguments must be given as list. Multiple arguments must be given as list. So that is why we are using two square brackets. One square brackets for subsetting. Second square bracket is multiple arguments must be given as a list or array in Python. Wherever you are giving multiple arguments, it has to be in the form of a list or array. Got it? Character indexing. Numeric indexing. Data frame name dot iloc, index location, square brackets, colon, comma, and call number. Colon, comma, and call number. If colon, comma is not given, it is row selection. This is for column selection. So colon, comma is given before the column number, it is column selection. If you don't give colon, comma, it will select the rows. Right. So take for example, let us see what is our price name 0, and Python starts from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the column number for price. Chicago BNB dot index location colon comma 9, sorry, colon comma 9 dot head. Price variable selected. If you don't give colon comma, row number 9 is selected. Dot allocation, index location. Colon comma for columns, without colon comma rows. Okay. Numeric indexing, multiple columns. Numeric indexing, multiple columns. Data frame name, dot iLocation, square bracket, colon comma, and within square brackets, columns. Whatever call numbers you want to give, you can give here. So Chicago BNB dot iLocation, square bracket, colon comma, square bracket, 9 comma 10 comma 11 colon 13 dot head. Oh, it is not taking colon, huh? Okay. Okay. Now, if you copy the same command and remove colon comma, it will select rows from 9 to 13. 9 to rows selection. 9, 10, 11, 12, and 13. Just remove colon comma. All right. So we'll stop here and we'll continue in the tomorrow's session. We'll start with the descriptive statistics. And then we'll do all the things what we have done in Excel in Python. Download as IPynb file. So you know how to open the IPynb file, right? First open the Jupyter Notebook. And then in Jupyter Notebook homepage, you will see desktop downloads, documents. Save anywhere there and you can open the file. So to open that .ipynb file, first you have to open Jupyter Notebook. Then from Jupyter, you can see here, downloads, desktops, and documents. Anywhere you can save the file and then you can open from there. Now, if you want to use the file which I am sending, you have to just change this folder path to your folder path. And make sure the file name is same. And then you can run and you can use the same notebook. Two changes. First, change the path to your folder and check the name of what the file is there. And then if you run these two cells, rest of all are same. So notes is there. I will give you as PDF also. So whenever there is notes, I will share the PDF also, so that you can refer to it. Now, whose email IDs are missing here? RAJ SHE KR SIYA 60 gmail.com. Yes, who else? Huh? That's right. Only one, huh? Who's? Durga? Ah. Okay.